Welcome to On Chemistry. This video series contains organic chemistry concepts. Today we are going to see how to find aromaticity. We are going to see benzenite compounds, ketones, charged conjugated compounds, benzenes, radical, twisted structures, and many more. I given 90 such examples with fully solved category. I given 90 fully solved examples for your easy and quick reference. Stay tuned. What is inside this video? First part of the video, we will see how to find aromaticity. We will go through Huckel rule and step-by-step procedure to identify the aromaticity. Examples mostly include aromatic compounds, anti-aromatic compounds, homoaromatic compounds, and quasi-aromatic compounds. We are going to see 90 fully solved examples for competitive exam advantage. So stay tuned. First, let us see Huckel rule and aromaticity. It's a very important thing. Without that, you cannot identify aromaticity. Let us see what is Huckel rule. You should memorize this table. Then only it will be easy to identify the aromatic compound. Here, three different factors are important. One is pi electron, another is planarity, and cyclic conjugation. Cyclic and should be conjugated. Aromatic means 4n plus 2 electron will be there. Planar and conjugated. Anti-aromatic means same, only difference is 4n. And non-aromatic means mostly non-planar or non-cyclic or non-conjugated. Then homoaromatic means you are creating the conjugation artificially. Then quasi-aromatic means it's a charged species. Most of the time quasi-aromaticity consider equally aromatic. So you can use both names interchangeably because stability also important to identify the compound. In stability point of view, aromatic is stable, anti-aromatic is unstable. How to find aromaticity? Very first step is counting the pi electron. Double bond you should count as 2 pi electron. Negative charge also count as 2 pi electron. Lone pair also 2 pi electron. But in the lone pair case, lone pair only participate to create the aromaticity. If the ring is already aromatic, lone pair won't participate. Then you have to find the electron series, which is 4n plus 2 or 4n. 4n plus 2 mean 2, 6, 10, 14 and so on. 4n mean multiples of 4. From that you can find aromatic, anti-aromatic. Then use the Huckel table to find whether it is aromatic compound, anti-aromatic compound, non-aromatic, homoaromatic or quasi-aromatic. Better memorize this table and the method. It's very simple, but the varieties are many. So you should memorize this table for quick and easy solving of problems. So we will see the examples 90. Why so many examples I given? Because problems are best way to learn. Problems will help you to think. Problems help you to calibrate your understanding of concepts. So problems are best way to learn. We start with very classical example, benzene, 3 triple bonds. This is a very simple system to understand the concept. So start with typical benzene. Benzene, if you count pi electron, it has 3 pi electron. So total contribution is 6 pi. There is no charge, no lone pair. So total pi electron is 6. It will come under 4n plus 2 because n is 1 mean you end up with 6 pi system. If you look at the conjugation, definitely it is conjugated. Definitely it's planar. All are sp2 carbons. So overall 4n plus 2 conjugation planarity means it's an aromatic compound. So this is the way to find the aromaticity. Then the next example, you have 7-member ring which is fused together. You should find whether the compound is aromatic or not. If you count the pi bonds, totally 6 pi bonds, so 12. There is no charge in the system, so 0 pi bonds. So lone pair 0, so 0 pi bond. So totally it has 4n pi electron. Meaning if you substitute 3, you have 12 pi electron, which is 4n system. So 4n system, conjugation means yes, it is definitely conjugated. So pi bond, double bonds are alternative. Planarity, all are sp2 carbon. So anti-aromatic system. Then the next example, you have cyclopentadiene with exocyclic double bond. You should find whether it is aromatic or not. So same method you should follow. First count the pi bond, 6 pi bonds. The one pi bond is exocyclic double bond. Definitely it will not contribute to the conjugation. But if you go usual pathway, it has 3 pi electron, no charge, lone pair is nothing. So 6 pi electron, which is 4n plus 2. But conjugation is not there. Planarity, yes, it is possible because all are sp2 carbon. Since the conjugation is not there, you can say it's a non-aromatic system. Then the example 4, you have androgen system, 3 benzene ring connected together. You should find whether the compound is aromatic or not. Here you should count the pi bond, totally 7 pi bonds, so 14 pi electron. No charge is there, so charge is 0. Lone pair is not there, so 0 pi electron. So totally 14 pi electron means it's a 4n plus 2 system with n equals 3. So 4n plus 2 system, conjugation definitely it is there. Planarity also there because all are sp2 carbons. So the ring is aromatic. So the given compound is aromatic. Then the cyclopropenyl cation, it's a very important one. You should find whether it is aromatic or not. Here positive charge is there, ring is there, only 1 pi bond. Positive charge, you don't count the electron. So totally 2 pi electron. 2 pi electron obey the Huckel rule because it's a 4n plus 2 system with n equals 0. So totally 2 pi electron. Conjugation, yes, because positive charge provides the conjugation. Planarity, yes, because positive charge is sp2 carbon. So all carbons are sp2. So the ring is aromatic. Since the charge is there, we should call as quasi-aromatic. Either you call aromatic or quasi-aromatic, doesn't matter. Both are considered as equal. Here, more specifically, it is quasi-aromatic. Then the next example, you have 10 carbon system, which is continuous cyclic compound with 5 pi bonds and you have hydrogens. You should find whether the given compound is aromatic or not. Here the compound is given. By blind sight you might commit the mistake because hydrogens are steric. The steric hydrogen forces the structure to be twisted. So the structure need not to be linear or planar. So structure need not to be planar and conjugated. So total aromaticity is destroyed. Even though it has 5 pi bonds, which is 10, no charge, lone pair is 0. So totally 4 and pi system with pi bonds, n equals 2 there. So 4n plus 2 system, but conjugation is destroyed because of twisting. Planarity also compromised because of twisting. So given structure is non-aromatic. Then the next example, you have pyridine. You should find whether pyridine is aromatic or not. Here pyridine is nitrogen analog of benzene. So nitrogen in the benzene. Pyridine has one nitrogen which has one lone pair, but lone pair don't participate. Why? Because the system is already aromatic, so lone pair participation not required. Lone pair only participate if it is necessary to create the aromaticity. So total pi bonds are 3, so 6 pi electron. Since there is no participation of lone pair 0 and totally 6 pi electron, which is 4n plus 2 pi electron where n equals 1. So 4n plus 2 system, conjugation is there, planarity is there. So given compound is aromatic. Then the next example, you have biphenyl system, 2 benzene ring connected through single bond. You should find whether the given compound is aromatic or not. This is the tricky question. Both rings are individually aromatic. If you count collectively, you might commit a mistake because both systems are aromatic. It is separated by single bond. So you should take only one benzene for analysis. So totally 6 pi electron, 3 pi bonds, 6 pi electron, which is come under 4n plus 2 where n is 1. So 4n plus 2 system, conjugation definitely it is there. Planarity yes. So the given compound is aromatic, or more specifically, both rings are individually aromatic. Then the next example, you have 6-member, 8-member, 6-member fused system with connected double bond. You should find whether the given compound is aromatic or not. If you count double bonds, it has totally 16 pi electron, which is 8 pi bonds. No charge is there, lone pair also not there. 16 is the multiple of 4. Simply you can say it's 4n pi electron where n equals 4. Conjugation definitely there. Planarity also definitely there. So 4n system mean it is anti-aromatic system. Then the next example, you have non-boron system with 3 double bonds. We should find whether the given compound is aromatic or not. The system has 6 pi bond, but it is non-planar, non-conjugated. So how do you do that? So simply you can say it is non-aromatic. Even though it has 6 pi electron from 3 pi bonds, charge is 0, lone pair is 0. So it will definitely fit under 4n plus 2 system where n equals 1, totally 6 pi. But it doesn't have any conjugation, no planarity. It's sp3 carbon on middle. So the given system is non-aromatic. Then the next example, you have cyclohexadiene with anion. We should find whether the given compound is aromatic or not. Here you have tricky situation. The chances of aromatic is there, only problem is sp3 hybridized carbon. So what really happened? The carbon go out of the plane, create the cyclic product, create the aromaticity. Let us count the pi electron in the raised carbon system. You have 2 pi bonds, so 4 negative charge, so 2 pi electrons, so totally 6 pi electrons. So 6 pi electron means it's a 4n plus 2 system with n equals 1. Here you are creating conjugation artificially, planarity also there. So system is homoaromatic. Homoaromatic system created by established conjugation or artificial conjugation. Then the next example, you have borosine, which is the inorganic benzene. Boron and nitrogens are in alternative position. You should find whether it is aromatic or not. It is called inorganic benzene. The reason is nitrogen lone pair and empty p orbital in the conjugation. So it is like cation anion kind of situation. Charge will travel through. So how many lone pairs are there? 3 lone pairs are there. So pi electrons are 6. Then no charge is there. So that is 0. So totally 6 pi mean 4n plus 2 where n equals 1. Conjugation definitely there. Planarity also there because of conjugation. So totally 4n plus 2 system, conjugation and planarity leads to the inorganic benzene aromatic possibility. So inorganic benzene is aromatic. Then the next example, you have heptane system with diene and 2 ketones. You should find whether the compound is aromatic or not. The system is kind of tricky because you are creating the aromaticity by ketoenol tautomerism. One ketone becomes enol mean you are gaining the aromaticity. So 3 bi-bonds in conjugation, partial positive charge which is delta plus provide the conjugation. So totally 3 bi-bonds, so 6 pi electron. So 6 pi electron mean it is 4n plus 2 system where n is 1, so totally 6. So conjugation is there, planarity is there, 4n plus 2. So the given compound is aromatic. Then the next example, you have benzene with one triple bond. You have to find whether it is aromatic or not. Benzene is a tricky system. It has one triple bond. So how many electrons you should count? Here triple bond means two pi bonds are perpendicular to each other. So one pi bond away from the system. So you should count only 2 pi electron. So 2 pi bond 2 pi electron. One triple bond also 2 pi electron. So totally 6 pi electron. It is a 4n plus 2 pi system where n is 1. Totally 6 pi electron. So system is 4n plus 2. Conjugation definitely there. Planarity definitely there. So the benzene is aromatic. Then the next example, you have 5-member heterocyclic system. Boron is there and diene. You should find given compound is aromatic or not. The boron has empty p orbital, that's why it is called Lewis acid. So it can provide conjugation. Mostly it will be considered like cation. So cation provides the conjugation. So 2 pi bonds are there, so 4. So total pi electrons are 4 mean it's a 4n system where n is 1. So 4n system, empty p orbital provide conjugation and definitely it is planar. So 4n system mean it is anti-aromatic compound. Then the next example, you have 10 carbon system with one bridged carbon, 5 bonds are conjugated. You should find given compound is aromatic or not. Here normally without the bridged carbon, system is steric and non-planar. To remove the steric hydrogen, the carbon position above the plane remove the steric hydrogen. So steric hydrogen removed by CH2, so it gains planarity. So if you count pi bond, totally 5 pi bond equal to 10 pi electron. So no charges, lone pair also 0 mean 10 pi electron is 4n plus 2 system where n is 2. So 10 pi electron, conjugation and planarity mean the given compound is aromatic. Then the next example, you have linear compound with conjugated double bond which is hexadiene. You should find whether the given compound is aromatic or not. Here conjugation definitely there, 4 pi electron system. The compound is not cyclic, so conjugation don't help for delocalization because delocalization is the key factor here. So conjugation is there but there is no delocalization. So definitely the compound is non-aromatic. Then the next example, here you have cyclopentadiene which is in the radical form. You have to find whether the radical is aromatic or not. Here you have radical. Radical is a tricky compound because the hybridization is in between sp2 and sp3. You can say it is between tetrahedral and trigonal planar. So the compound is non-planar. Straight away you can say it's non-aromatic compound. But if you go by facts, it has 2 pi bonds, so 4. Charge is 0, lone pair is 0. It's a 4n system, so it is expected to be anti-aromatic. Since there is no conjugation, no planarity, it's a non-aromatic compound. Simply all radicals are non-aromatic. Then the next example, you have cyclobutene with dianion. You should find the given compound is aromatic or not. The compound has one pi bond, so 2 pi, but it has two negative charges, so totally 4 pi electron. If you consider pi electron from negative charge and pi bond mean totally 6 pi electron. 6 pi electron is 4n plus 2 system where n equals 1. So 4n plus 2 system, the negative charge provides conjugation and definitely it is planar, so the compound is aromatic. Then the next example, you have fused system 7 member and 5 member. It is called azulene. You should find whether the azulene is aromatic or not. Azulene is the beautiful cyclic system with 10 pi electron. There is 5 pi bonds, so totally 10 pi electron. No charge, no lone pair. So it's a 10 pi mean 4n plus 2 system where n is 2. So 4n plus 2 system, conjugation definitely there. It is cyclic and planarity definitely there. All are sp2 carbons. So the given compound is aromatic. Then the next example, you have 5 member heterocyclic system with 2 nitrogens and 2 pi bonds. We should find whether the given compound is aromatic or not. The compound has 2 nitrogens. It can give 2 electrons to the system. It can give 2 lone pair to the system, but only one donate, which is A nitrogen. A nitrogen donates. Why? Because it creates conjugation as well as aromaticity. So lone pair only participate to create the aromaticity. So pi electrons are 4. Lone pair gives 2 pi electron. So totally 6 pi electron. It's a 4n plus 2 system with 6 pi electron. So conjugation definitely yes, planarity yes. So the given compound is aromatic. Then the next example, you have cyclobutadiene. You should find aromatic or not. The system is simple with 2 pi bonds, so totally 4 pi electron. No charge is there. Lone pair also 0. So totally 4 pi mean it's 4n system where n equals 1. Conjugation definitely there. Planarity definitely there because all are sp2 carbons. So 4n conjugation and planarity mean anti-aromatic compound. Then the next example, you have fused system with bridged carbon. It has 2 7-member ring connected through bridged carbon. Pi bonds are conjugated. You should find given compound is aromatic or not. The given compound has 12 pi electron, totally 6 pi bonds. The charge is not there, lone pair is not there, so 0. So totally 12 mean it's a 4n system where n equals 3. Conjugation definitely there. All are sp2 carbon except bridge, so it's planar. So 4n system, conjugation, planar mean anti-aromatic compound. In the interesting example, you have benzene and 8-member fused system, the 2 triple bond and 1 double bond. We should find given compound is aromatic or not. Triple bond only contribute 2 pi electron due to perpendicular p orbitals. Already we seen, so you have to count only 2. So totally 4 double bond, 1 triple bond mean it's a 6 pi bond which is 12. Charge is 0, lone pair is 0. 12 pi electron mean it's a 4n system where n is 3 gives 12 pi electron. Conjugation definitely there. Planarity also there. So 4n conjugation planar mean it's anti-aromatic system. Then the next example, you have aniline system with 6 double bonds. You should find the given compound is aromatic or not. You have 6 pi bond mean 12 pi electron. No charge in the system. Lone pair also not there. So totally 12 pi electron mean it's a 4n system where n equals 3. So 4n system and conjugation definitely there, cyclic compound. Then planarity definitely there because all are sp2 carbon. So 4n conjugation planar mean it is anti-aromatic compound. Then the important example, cyclooctatetraene. People used to call it as COT. You should find COT is aromatic or not. The problem in the blind side, Actually, the compound is dub shape or non-planar shape. Because of strain, it bend and relieve the strain. So it totally 8 pi electron, which is 4 pi bonds. Charge is 0, lone pair is 0. So totally 8 pi electron means it's a 4n system. Totally 8 pi electron. So n equals 2. So 4n system, but it suffered by 0 conjugation, non-planar. So definitely the compound is non-aromatic because of dub-like shape. Then the next example, you have fused system, 6 member, 4 member and 6 member. All are conjugatively connected through double bonds. You should find the given compound is aromatic or not. The compound is cyclic. It has 12 pi electron because 6 pi bonds are there. 12 pi. Then charge is 0. Lone pair is 0. So the compound is 4n pi system with 12 electron. N is 3. So 4n system. Conjugation definitely there. It is cyclic compound. All are sp2 carbons. So planarity is there. So 4n conjugation. Planar mean the given compound is anti-aromatic. Then the next example, you have fused system with 5 member and 5 member. All are conjugated. You should find given compound is aromatic or not. The lesser double bond systems are easy and quick to calculate. Here 4 pi bonds are there. So totally 8 pi electron. Charge is 0. Lone pair is 0. 8 pi electron means it's a 4n system where n equals 2. Conjugation definitely there. It's a cyclic compound. Planarity definitely there because all are sp2 carbons. So 4n conjugation planar means it's anti-aromatic compounds. Then the next example, you have fused system with heterocyclic nitrogen. It has amine as well as connected aromatic like architecture. The compound is called adenine. You should find is it aromatic or not. Adenine has many nitrogen but only one donate the lone pair to create the aromaticity because you have 4 pi bonds, so 8 pi electron. Charge is not there but only one lone pair participates, so it's a 2 pi system, so it donates 2 pi electron, so totally 10 pi electron. So 4n plus 2 system with 10 pi electron where n equals 2 and conjugation definitely there. So one nitrogen donate the electron and promote the conjugation. Compound is definitely planar, so the given compound is aromatic. Then the macromolecule azulene system with many double bonds and longer ring size. You should find the given compound is aromatic or not. One way to find the quick aromaticity is count the pi bond. Here 8 pi bonds are given. I given number here. So 8 pi means 16 pi electrons. So charge is 0, lone pair is 0. 16 means 4n system where n equals 4 and conjugation definitely there. It's a cyclic compound. Then planarity definitely there. So 4n conjugation planar means the given compound is anti-aromatic. Then the next example, you have indole in the system, benzene and fused nitrogen system. You should find whether the indole is aromatic or not. Indole has 4 pi electron but 1 nitrogen. Nitrogen can donate the lone pair to create the aromaticity. So nitrogen can participate the delocalization and donate the electron. So totally 10 pi electrons. So 8 pi electron from double bond, 2 from lone pair. So totally 10 mean it's a 4n plus 2 system where n is 2. The conjugation definitely there because nitrogen lone pair provide conjugation and planarity definitely there. It's a cyclic system. So 4n plus 2 conjugation planar mean the given indole is aromatic. Then the next example, Here cycloheptanone is given with 3 double bonds. All are conjugated. We should find compound is aromatic or not. Here you have 3 pi bonds and ketone. Ketone carbonyl provide the partial positive charge because of electronegative oxygen. So it can provide delocalization possibility. It cannot donate the electron because it's a positive charge, but it can provide the conjugation and delocalization. So totally 3 pi bonds, so 6 pi bonds. Charge is +1, but no pi electron it can donate. So totally 6 pi system, which is 4n plus 2, where n equals 1. And conjugation definitely there because partial positive charge provide the conjugation, and planar definitely because all are sp2 carbons. So 4n plus 2 conjugation. Planar mean the given compound is aromatic. Then the next example, you have heterocyclic system with 2 nitrogens. We should find whether it is aromatic or not. Here 2 nitrogens are there, but ring is already aromatic. One important fact about lone pair is lone pair don't participate if it is not required. Since the ring is already aromatic, lone pair don't participate. So 3 bi bonds are there. So 6 pi electron, charge is 0. Lone pair don't participate, so 0 pi electron. So totally 6 pi electron. It is a 4n plus 2 system with n equals 1, and conjugation definitely there. Planarity also there. So 4n plus 2 conjugation. Planar mean the given compound is aromatic. Then the next example, you have benzene and cyclopentene with anion fused together. You should find the given compound is aromatic or not. Here you have fused system with anion. So totally 10 pi electrons. How? Because you have 4 pi bonds which donate 8 pi electron. Charge is -1 which can donate 2 pi electron. Lone pair is 0. So totally 10 pi electron, which is 4n plus 2 system where n equals 2. The system definitely in conjugation because negative charge provide conjugation. Planarity also there. So 4n plus 2 conjugation, and planar mean the given compound is aromatic. In the next example, you have cyclobutene with cation. You should find whether it is aromatic or not. By blind sight you might commit a mistake, but it is a homoaromatic system because one carbon go out of the plane, create the cyclic compound which promote the delocalization. The cation helps for delocalization as well as connectivity. So the compound become aromatic because it has only one pi bond and positive charge. Totally 2 pi electrons. 2 pi electron mean 4n plus 2 system with n equals 0. So conjugation you are created artificially, and planarity definitely there. So system is homoaromatic. Then the next example, here cyclohexadiene is given. You have to find whether the given compound is aromatic or not. By looking at it, you might realize it's a very simple compound. Why the question is given? Because you have to be always open and given the possibility of non-aromatic compound. Simply non-aromatic compound, even though it has conjugation, 4 pi electron, cyclic, but the system is not conjugated, planarity is there. So the given compound is non-aromatic. Then the next example. Here cycloheptatriene is given, cation is there. We should find the given compound is aromatic or not. In plain sight you may think it's non-aromatic because of loss of conjugation, but if you lift a carbon out of the plane, you create the aromaticity. This is called homoaromaticity. You are creating artificial conjugation. This is possible because aromaticity creates extreme stability. If you count pi electrons, it has 3 pi bonds, so 6 pi. Charge is plus 1, so 0 pi electron. Lone pair is 0, so 4n plus 2 pi system where n equals 1, which contain totally 6 pi electron. Conjugation, yes, artificially created. Planarity also there. So the given compound is homoaromatic. Then the next example, you have cycloheptatriene with one sp3 carbon inside. You should find the given compound is aromatic or not. Here sp3 carbon is there. It's a tetrahedral in nature. So definitely it is non-planar. It will prevent the conjugation as well as delocalization. So conjugation is there, but sp3 carbon prevent the extension and delocalization. But if you go in the normal pathway, it has 3 pi bonds, 6 pi electrons, charge is 0, lone pair is 0, so 4n plus 2 pi electron. So 6 pi system, conjugation is not there because of sp3, planarity is also not there, so the given compound is non-aromatic. Then the next example, you have cyclohexene, exocyclic conjugated diene is there. You should find the compound is aromatic or not. Compound has conjugation, yes, it is a 6 pi system because it has 3 pi bonds. No charge is there, no lone pair is there. So 4n plus 2 pi electron. So totally 6 pi electron where n equals 1. So 4n plus 2 system means 6 pi electron. System is conjugated but not cyclic because you have to consider only double bond position, not the cyclic compound. Double bonds are not cyclic in the section, so delocalization not possible. Planarity definitely there. Since there is no delocalization, the compound is non-aromatic. Then the next example, you have cyclooctatriene system. It is a dianion. You should find the compound is aromatic or not. So negative charge is there. Negative charge help for the conjugation. So we will go by normal route. Totally 3 pi bonds are there, 6 pi. Charge is 2 minus, so 4 pi electron. So if you count totally pi electron mean 10 pi electron, which is 4n plus 2 system with n equals 2. Conjugation definitely there. Planarity definitely there. So 4n plus 2 system, conjugation, planar means the given compound is aromatic. Then the next example, you have benzene. It connected with diketone which is in the 5-member ring and it's also a cation. We should find the given compound is aromatic or not. Here two types of charges are there, partial and full charges. Both can help for delocalization, but positive charge don't contribute to any electrons. So only pi bond is our interest. So 3 pi bonds, 6 pi electron, lone pair is 0, charge don't contribute. So totally 6 pi electron, which is 4n plus 2 system with n equals 1. Conjugation promoted by partial and full charges. Planarity definitely there because all are sp2 carbons. So 4n plus 2 conjugation. Planar mean aromatic system. Then the next example, you have cyclobutene with dication. You have to find the compound is aromatic or not. Here dication is there, you have alkene. It's a 2 pi system because only 1 pi bond. The cation can help for delocalization. So let us analyze the possibility. It has 1 pi bond, so 2 pi electron. Charge is plus 2, plus charge don't contribute for pi, so 0 pi electron. No lone pair, so 0. It's a 4n plus 2 system where n equals 0 with 2 pi electron and it has conjugation because positive charge help for the conjugation. The compound is definitely planar because all carbons are sp2 hybridized. So the given compound is aromatic. So 4n plus 2 system, conjugation, planar mean the given compound is aromatic. Then the next example, here you have cyclopentadienyl anion. You should find the compound is aromatic or not. Here you have negative charge. Negative charge can help for the delocalization as well as conjugation. So let us analyze the possibility. It has 2 pi bonds, so 4 pi, and charge is -1, so 2 pi. Lone pair is not there, so 0. So totally 6 pi electron, which is 4n plus 2 system where n equals 1. Conjugation definitely there. Planarity also there. So 4n plus 2 conjugated planar, and it is charged means it's quasi-aromatic, and you may also consider it as aromatic. Then the next example, you have heterocyclic system with ketone, you have alkene, and you have electron, and you have lone pair in the oxygen. You should find the given compound is aromatic or not. The given compound has 6 pi electron, 2 from pi bond, oxygen has lone pair. Trick is carbonyl. Carbonyl has partial positive charge, so it has the possibility of delocalization as well as conjugation. So if you go by normal pathway, 2 pi bonds mean 4 pi electron, charge is not there, so 0. Lone pair 1 is there, so 2 pi. So 4n plus 2 system with 6 electron where n equals 1. It has definitely conjugation and planarity. So the given compound is aromatic. Then the next example, you have cyclooctatetraene. You have cyclooctatetraene with dication. You should find the given compound is aromatic or not. Here cation is there. You may wonder how the delocalization is possible. Here cation can help for conjugation as well as delocalization. So if you go by normal pathway, 3 pi bond, so 6 pi electron, charge is +2, so 0 pi electron, because positive charge don't contribute for the pi electron system. So lone pair is 0. Totally 6 pi electron with 4n plus 2 system where n equals 1. The compound is conjugated and planarity is there because all carbons are sp2 hybridized, all are planar. So the given compound is quasi-aromatic. Then the next example, you have cyclobutene system with diketone. You have to find the given compound is aromatic or not. Here ketone is there. It's an interesting system because ketone form partial positive charge which can help for delocalization. It is like full positive charge, but partial positive charge also behaves same. So the system is conjugated and delocalized. So if you go by normal pathway, it has 1 pi bonds, so 2 pi electrons, charge is 0, lone pair is 0. So 4n plus 2 pi electron mean it has 2 pi, so n equals 0. Conjugation definitely there because positive charge helps, and planarity definitely there because all are sp2 carbons. So 4n plus 2 conjugated. Planar mean the given compound is aromatic. Then the next example, you have cyclopentadiene and you have anion. It is like diazonium salt. You should find the given compound is aromatic or not. Here anion is there. Anion is like cyclopentadienyl anion. So you can go by normal pathway. So pi electron is there, which is 2 pi bonds, which is 4 pi electron. Charge is -1. So you should count 2 pi electron. Lone pair is not there, so 0. So it is a 4n plus 2 system with 6 pi electron where n equals 1. Conjugation definitely there because negative charge provides the conjugation. Planarity definitely there. So the given compound with charged conjugation means the compound is quasi-aromatic. Then the next example, you have cyclopropene with fluoride. You should find the given compound is aromatic or not. As you are aware, fluorine is the most electronegative element, so it can pull the electron towards itself, so it forms partial positive charge on nearby carbon, so it is like cyclopropenyl cation. Cation is there, conjugation is created, so pi electron means 1 pi bond, 2 pi electron, charge is plus 1, so don't count pi electron, lone pair is 0. It is a 4n plus 2 system where n is 0 with 2 pi electron. The system is definitely conjugated, and the partial positive charge ring strain create almost planar compound. So 4n plus 2 conjugated planar mean the given compound is aromatic. Then the next example, you have cycloheptatriene which is in the ketone form. We should find the compound is aromatic or not. Here carbonyl is there. Carbonyl has electronegative oxygen. So partial positive charge developed at the carbon. So systems are conjugated. Further conjugation promoted by partial positive charge. So let us analyze the possibility of aromaticity. It has 3 pi bond. So 6 pi electron. Charge is 0. Lone pair is 0. So it is a 4n plus 2 pi electron system with 6 pi electron where n equals 1. The system is definitely conjugated and compound is planar because of continuous sp2 hybridized carbon. So 4n plus 2 system conjugated planar mean the given compound is aromatic. Then the next example, you have cyclopropenyl anion. You should find whether it is aromatic or not. Here you have negative charge. Negative charge helps for conjugation and delocalization. So negative charge you have to account it. So pi bond means it's a 1 pi bonded system. So 2 pi electron. Charge is minus 1. So 2 pi electron also there. Lone pair is not there. So it is 0. So it's a 4n pi system where n equals 1 with 4 pi electron. Conjugation definitely there. Planarity promoted by forcible ring strain. So the given compound is anti-aromatic. Then the next example, you have higher order fused system. 4 rings are fused together with many pi bonds. You got to find the given compound is aromatic or not. Here the important fact is only periphery electron or surface electron participate in the conjugation. Middle one cannot be participated because of size and plate-like architecture. So we should consider only 7 pi bond, not 8 pi bonds. So 7 pi bond means it's a 14 pi electron system. Charge is 0. Lone pair is 0. So it is a 4n plus 2 system with 14 pi electron where n equals 3 and conjugation definitely there. Planarity is promoted because of sp2 carbon. So 4n plus 2 system conjugated planar mean the given compound is aromatic. Then the next example, you have cyclopentadienyl cation. You should find the compound is aromatic or not. Here you have cation. Cation help for conjugation with delocalization. So you have 2 pi bond in the system. So 4 pi electron. The charge contributes 0 pi electron because it is a cation. So lone pair is not there. So 0 pi electron. So it's a 4n system with 4 pi electron where n equals 1. Conjugation definitely there because positive charge helps it. Because positive charge helped it. And planarity is possible because all are sp2 carbons. So 4n conjugation planar mean the given compound is anti-aromatic. Then the next example, you have cyclopentadienyl with ketone form. You should find the given compound is aromatic or not. Here ketone is there. Ketone provide partial positive charge. It also help for the conjugation. So we can go by normal procedure. So it has 2 pi bond. So 4 pi electron. charge is 0. So lone pair also 0. So totally 4 pi electron. So it's a 4n system with 4 pi electron where n equals 1. The system has conjugation because positive charge helps the conjugation, and planarity definitely there because all are sp2 carbon. So 4n system, conjugation, planar mean the given compound is anti-aromatic. Then the next example, you have cyclobutene with cation and anion. You should find the given compound is aromatic or not. Here system given with the twist, you can consider cation and anion like cyclobutadiene, but here given as charge. So let us analyze the possibility. Positive charge and negative charge help for the conjugation. So totally 1 pi bond, which is 2 pi electron. Charge minus and plus is there. Minus provide 2 pi electron. Lone pair 0. So 4 and pi system with 4 pi electron where n equals 1. Conjugation definitely there because charges help the conjugation. Then planarity also there. So it's a 4n system. Conjugation. Planar mean the given compound is anti-aromatic. Then the next example, you have cyclohexadiene with dication. You should find the given compound is aromatic or not. Here the compound has cation. It is positive charge which can help the conjugation and delocalization. So if you count totally pi electron, which is 2 pi bonds, 4 pi electron, charge is plus 2 which gives 0 pi electron, lone pair is 0. So it is a 4n system with 4 pi electron where n equals 1. Conjugation definitely there. Planarity also promoted by sp2 carbons. So compound has 4n system, conjugation, planar mean it's anti-aromatic compound. Then the next example. Here you have pyrrole which is protonated with cation. You should find the given compound is aromatic or not. Here positive charge is there. Positive charge can help for the delocalization. It has 2 pi bonds which is 4 pi electron. Charge is plus 1, so 0. So it cannot contribute. So 0 pi electron. It has one lone pair but it is protonated. So it don't have any lone pair. So it's a 4n system with 4 pi electron where n equals 1. Conjugation definitely there because cation helps the conjugation, and planarity also there because of sp2 carbons. So 4n conjugated. Planar mean the given compound is anti-aromatic. Then the next example. Here you have heterocyclic system with double bond and lone pair and anion. You should find the given compound is aromatic or not. This compound is interesting because it has all possibility, anion, lone pair, conjugation, many concepts inside. Here negative charge can help for the delocalization, but oxygen also participate here because to promote the conjugation. So 4 electrons involved. So pi electron means 2 pi bonds, 4 pi electron. Charge is minus 1 which is 2 pi electron. Lone pair definitely participate to create the conjugation. So it is also 2 pi electron. So it is a 4n system with 8 pi electron where n equals 2. It is conjugated because lone pair and anion help for the conjugation. Planarity definitely there. So 4n system, conjugated. Planar mean it's anti-aromatic compound. Then the next example. Here you have cycloheptatriene with oxygen, which is the heterocyclic compound. You should find the given compound is aromatic or not. Here by blind sight you might commit a mistake because oxygen is look like linear and planar. Oxygen is sp3 hybridized. It's a tetrahedral non-planar system. So lone pair also in the non-planar. So don't involve in the conjugation. So totally 3 pi bond means 6 pi electron. Charge is 0. Lone pair don't participate, so 0. So 4n plus 2 system with pi electron, which is 6, where n equals 1. It's a 4n plus 2 system, but conjugation definitely not there because of sp3 carbon. Planarity also not there because of tetrahedral nature. So 4n plus 2, no conjugation, no planarity, mean the given compound is non-aromatic. Then the next example, here you have large molecule with many pi bonds and big ring structure. Technically it is called aniline. You should find the given compound is aromatic or not. Here you have 14 aniline, meaning 14 carbon with 7 pi bonds. So if you count the pi bond, it is 7. So totally 7 pi bonds, 14 pi electron. Charge is 0, lone pair is 0. So it's a 4n plus 2 system with 14 pi electron, where n equals 3. Conjugation definitely there because alternative double bond, and planarity definitely there because of sp2 carbon. So 4n plus 2 system, conjugation, planar mean the given compound is aromatic. Then the next example, you have macromolecule with many double bonds and large ring structure. You should find the given compound is aromatic or not. As we discussed already, the given compound is aniline, but it has steric hydrogen, which is hidden in the question. If you redraw, you have steric hydrogen. So the compound is non-planar because of steric strain. As a result, it is non-conjugated. So it has 8 pi electron, 16 pi. Irrespective of pi electron, you are not having any conjugation or planarity due to steric effect. The given compound is non-aromatic. So non-planar means straight away you can write it's a non-aromatic compound. Then the next example, you have buckyball, meaning Buckminster fullerene with 16 carbon. You should find the given compound is aromatic or not. The given compound is very beautiful like football. It's a 16 carbon system, but it's completely non-planar because of bend and forced spherical structure. So non-planar, definitely non-conjugated. So it has 30 pi bond, 16 pi electron. Charge is 0, lone pair is 0. It will come under 4n category with n equals 15. But non-planar structure don't involve any conjugation and definitely don't have any planarity. The compound considered to be non-aromatic because many literature claims that partial aromaticity is known, but structure as a whole definitely non-aromatic. Then you have heterocyclic system. The two nitrogen in the ring, one amine and ketone is there. You should find the given compound is aromatic or not. The compound is biomolecule with heterocyclic nitrogen and carbonyl. Carbonyl provide partial positive charge. Nitrogen, which is circle 1, provide lone pair. So lone pair and partial positive charge provide the conjugation. So if you count pi bonds, 2 pi bonds, so 4 pi electrons, charge is 0. Lone pair only one participate, which is 2 pi electron, and you have 4n plus 2 system with 6 pi electron where n equals 1. Here the compound is definitely conjugated. Planarity definitely promoted. So 4n plus 2 system conjugated. Planar mean the given compound is aromatic. Then the next example, you have aniline system, which is a smaller macromolecule with conjugated double bonds. We should find the given compound is aromatic or not. The compound is 12 aniline. 12 aniline means which has 6 pi bond, totally 12 pi electron. Charge is 0, lone pair is 0. So it's a 4n pi electron, where n equals 3 means it's a 12 pi electron. So it's a 4n system. Conjugation definitely there. Planarity definitely there because of all sp2 carbons. So 4n conjugated. Planar means it's anti-aromatic compound. Then the next example, you have macrocyclic molecule with continuous double bond. You should find the given compound is aromatic or not. The compound is technically called aniline. While analyzing aniline, better count the pi bonds directly. Here it has 9 pi bond. So totally 18 pi electron system. Charge is not there. Lone pair is not there. So 18 pi electron means it's a 4n plus 2 system. The 18 pi electron, n equals 4. Conjugation definitely there. Planarity definitely there because of all sp2 carbon. So 4n plus 2 conjugated. Planar means the given aniline is aromatic. Then the next example, you have continuous aniline system but connected through the bridged carbon. Two bridged carbon positioned as strands. You should find the compound is aromatic or not. Normally without the carbon, the compound is non-planar because of steric hydrogen. The planarity created by the methylene bridges. So it has totally 7 pi bond with 2 methylene bridges. So 7 pi bond means 14 pi electron. Charge is 0. Lone pair is 0. So it's a 4n plus 2 system with 14 pi electron where n equals 3. Conjugation definitely there because steric effect is removed. Planarity definitely there. So 4n plus 2 conjugated. Planar means the given compound is aromatic. Then the next example, here you have pyrrole, which is 5-member heterocyclic system with double bond and nitrogen. You should find the given compound is aromatic or not. Here the compound has conjugation and lone pair. Lone pair can help for the delocalization because then only the compound become aromatic. So it has 2 pi bond, which is 4 pi electron. Charge is 0. It has one lone pair, so 2 pi electron which can help for the conjugation. So it is a 4n plus 2 system with 6 pi electron where n equals 1. It has definitely conjugated because lone pair provide the conjugation. Planarity definitely there. So 4n plus 2 conjugated. Planar means the given compound is aromatic. Then the next example, you have fused system with 4 member, 6 member, 6 member, 4 member. All are connected through single and double bond. You have to find the given compound is aromatic or not. It is a large macromolecule. Better you count the pi bonds. It has 7 pi bonds, so which is 14 pi electron. No charge is there. Lone pair also not there. So it's a 4n plus 2 system with 14 pi electron where n equals 3. Conjugation definitely there. All ring carbons are sp2 hybridized, so it is planar. So 4n plus 2 system conjugation. Planar means the given compound is aromatic. Then the next example, you have macrocyclic system. Basically, it's a continuous connecting hexagonal benzene-like architecture. You should find the given compound is aromatic or not. Such a large system, you should count the pi bond, but you should be careful that only surface electron participate, not the middle electron. Since planarity is compromised on middle, so only surface or periphery electrons are counted. So it has 9 pi bond, which is 18 pi electron. Charge is 0, lone pair is 0. So it is a 4n plus 2 pi electron, which is 18 pi electron where n equals 4. Conjugation definitely there. Planarity is promoted by sp2 carbon. So the given compound is aromatic. Then the next example, here you have furan, which is heterocyclic system with oxygen and double bond. You should find the given compound is aromatic or not. Here oxygen has two lone pair. It can help with one lone pair create the conjugation as well as aromaticity. So one lone pair help for delocalization as well as conjugation. So if you count the pi electron, 2 pi bond, so 4 pi electron, no charge is there, so 0 pi electron. It has only one participation of lone pair, so 2 pi electron. So it is a 4n plus 2 system with 6 pi electron where n equals 1. Then the compound is conjugated because lone pair helped it and planarity also there. So it's a 4n plus 2 system conjugated. Planar means the given compound is aromatic. Then the next example. Here you have fused system which is naphthalene connected through two alkene carbon. We should find the compound is aromatic or not. Here it is a fused system with middle pi electron. Middle pi electron don't participate because of non-planar structure. So only you should count surface or periphery electron. If you count the pi bonds, you have 5 pi bonds which is 10 pi electron. Charge is 0, lone pair is 0. So it is a 4n plus 2 system with 10 pi electron where n equals 2. So it is 4n plus 2 system conjugated. Planar mean the given compound is aromatic. Then the next example. You have macrocyclic compound which is technically aniline connected through alternate double bond and single bond. You should find whether the given compound is aromatic or not. While analyzing aniline, we should count the pi bond. Here totally 10 pi bonds, so 20 pi electron. There is no charge, no lone pair. 20 means it's a 4 and pi system where n equals 5. Conjugation definitely there. Planarity definitely there. So 4n system, conjugation, planarity means the given compound is anti-aromatic. Then the next example, here you have heterocyclic system with amine and carbonyl. Basically it's amide architecture. We should find the compound is aromatic or not. The compound is actually a hetoenol tautomerism. Here it is in heto form. Still we can prove it is aromatic. Here one lone pair and carbonyl. Carbonyl has partial positive charge. Lone pair has electron. Both help for delocalization as well as lone pair can donate the electron. So if you count the pi electron, it's a 2 pi bond. So 4 pi electron. Charge is 0. So lone pair 1 equals 2 pi electron. It's a 4n plus 2 pi electron system where n equals 1 with 6 pi electron. It has conjugation because lone pair and carbonyl can provide the conjugation. It is planar. So 4n plus 2 system, conjugation. Planar means the given compound is aromatic. Then the next example, you have heterocyclic system with nitrogen and oxygen. You should find the given compound is aromatic or not. Here you have 5-member system with nitrogen and oxygen. Oxygen should donate the lone pair because it should establish the conjugation. So totally 2 pi bonds, so 4 pi electron. Charge is 0. 1 lone pair participates which equals 2 pi electron. So it is a 4n plus 2 system with 6 pi electron. N equals 1. It has conjugation because lone pair can help the conjugation. The compound is planar. So 4n plus 2 system, conjugated, and planar means the given compound is aromatic. Then the next example, you have bridged amine which is connected in the naphthalene. You should find the given compound is aromatic or not. Here similar kind of situation we already seen with carbon. Here it is with amine. The results are same. If the hydrogen is there, you have steric position. The compound will be non-planar. So bridged amine helps to relieve the steric effect. So steric effect is removed. If you count the pi bonds, 5 pi bonds, 10 pi electron, charge is 0, lone pair is 0. So it is a 4n plus 2 pi electron system with 10 pi electron where n equals 2. Here conjugation established by amine bridges. Planarity also there because the conjugation it is in planarity. So 4n plus 2 conjugated planar mean the given compound is aromatic. Then the next example you have thiophene which is 5-member system with sulfur and 2 pi bonds. We should find the compound is aromatic or not. Here you have sulfur. Sulfur has 2 lone pair. The lone pair can help to create the aromaticity, but only one should participate. So 1 pi electron participate help for delocalization and conjugation. So totally 6 pi electron. So 2 pi bonds which is 4 pi electron. Charge is 0. Only one lone pair participate. So 2 pi electron. So it is the 4n plus 2 system with 6 pi electron where n equals 1. The lone pair help for the conjugation and planarity also established. So 4n plus 2 system conjugated planar means the given compound is aromatic. Then the next example you have heterocyclic system with 2 nitrogen and double bond. We should find the given compound is aromatic or not. This question is interesting because it has 2 nitrogen A and B, but only one donate the electron which is A because it should donate the electron to create the conjugation to create the aromaticity. B don't donate, only A donate. If you count pi bonds, it has 2 pi bonds with 4 pi electron. Charge is 0, lone pair is 1 which is 2 pi electron, which is 4n plus 2 system with pi electron where n equals 1. The conjugation definitely there because lone pair help for conjugation. Planarity also there. So 4n plus 2 conjugated and planar mean the given compound is aromatic. Then the next example which is similar to the previous one. Only heterooxygen is there. It's a 5-member ring. 2 pi bonds, 1 nitrogen and oxygen. We should find the given compound is aromatic or not. Here nitrogen lone pair is critical because it should help for conjugation as well as aromaticity. Even though system has many lone pair, only nitrogen donate the lone pair. So if you count the pi electron, so 2 pi bonds, 4 pi electron, charge is 0, lone pair is 1 which gives 2 pi electron. So it is a 4n plus 2 pi system with 6 pi electron where n equals 1. Then the conjugation definitely there because lone pair helped it and planarity definitely there. So it's a 4n plus 2 conjugated. Planar mean the given compound is aromatic. Then the next example, you have heterocyclic system with heterocyclic nitrogen, ring nitrogen and carbonyl compound. We should find the compound is aromatic or not. Here the system is interesting because it involves 2 different concepts, lone pair and charges on the carbonyl. Here 2 nitrogen is there, both will donate the lone pair. 2 carbonyl is there, both support the delocalization because partial positive charge help the delocalization. Nitrogen lone pair give the pi electron. So if you count the pi electron, only 1 pi bond, 2 pi electron, no charge and 2 lone pair participate. So 4 pi electron. So totally it's a 4n plus 2 pi electron system with 6 pi electron where n equals 1. Here conjugation definitely there because lone pair and partial positive charge help for the conjugation and planarity definitely there. So 4n plus 2 conjugated planar mean the given compound is aromatic. Then the next example, you have heterocyclic system which is fused 6-member and 5-member with many nitrogen and carbonyl. You should find the given compound is aromatic or not. As we discussed already, even though many nitrogen is there, nitrogen can donate the lone pair to help the aromaticity. Here two lone pairs are highlighted. It will help both the aromaticity and conjugation. So if you count the pi bond, totally 3 pi bond, so 6 pi electron, charge is 0. Two lone pair help for the aromaticity, so 4 pi electron. So totally 10 pi electron, which is 4n plus 2 pi system with 10 pi electron, where n equals to conjugation definitely there because partial positive charge and lone pair support the delocalization, and planarity definitely there. So 4n plus 2 system, conjugation, and planar means the given compound is aromatic. Then the next example, you have fused system 5 member and 6 member. 5 member with heterocyclic oxygen. We should find the given compound is aromatic or not. Here you have oxygen which has two lone pair, but it can help for delocalization and aromaticity. So only one lone pair participates. If you count the pi electron, it is 4 pi bonds with 8 pi electron. Charge is 0. Only one lone pair participates. So 2 pi electron. So it is a 4n plus 2 pi system with 10 pi electron, where n equals to conjugation definitely there because lone pair support it, and planarity also there. So 4n plus 2 conjugated planar mean the given compound is aromatic. Then the next example, you have heterocyclic nitrogen which is fused with two benzene ring. You should find the given compound is aromatic or not. Here you have two separate pi bonded system. So you should consider separately like biphenyl because nitrogen and hybridizations are different. sp3, it is non-planar, but the ring is individually planar and aromatic. So for the one ring, if you count the pi electron, it's a 3 pi bond. So 6 pi electron, charge is 0, lone pair is not there, so 0 pi electron. So it is a 4n plus 2 pi system with 6 pi electron, where n equals 1. It has definitely conjugation inside the ring. Planarity also there because of sp2 hybridized carbon. So 4n plus 2 conjugated planar mean the given compound is aromatic. Then the next example, you have heterocyclic system with pi bond, oxygen and cation is there. You should find the given compound is aromatic or not. Here the compound is interesting because it has lone pair and cation. Both help for the delocalization. Further, lone pair participate in the delocalization to create the aromaticity. So if you count the pi bond, 2 pi bonds are there. So 4 pi electron. Charge is there, positive charge. So 0 pi electron. And lone pair you have one set which is 2 pi electron. So 4n plus 2 pi system with 6 pi electron, where n equals 1. The system is definitely conjugated because lone pair and cation help for delocalization. Compound is also a planar. So 4n plus 2 conjugated planar mean the given compound is aromatic. Then the next example, you have heterocyclic system with alternative nitrogen and carbon connected through alternative double and single bond. You should find the given compound is aromatic or not. Here the ring is already aromatic. Nitrogen cannot participate in the aromaticity. So if we do the mere calculation, it has 3 pi bond. So totally 6 pi electron. Charge is 0. Lone pair cannot participate because it will destroy the aromaticity. So it is a 4n plus 2 pi electron system with 6 pi electron, where n equals 1. Here conjugation definitely there and planarity also there. So 4n plus 2 conjugated planar mean the given compound is aromatic. Then the next example, here you have aniline system with bridged oxygen. We already seen carbon and nitrogen. Here oxygen is given. We should find the given compound is aromatic or not. Here the hydrogens are steric in this kind of compounds. So bridged atoms can relieve the steric effect. So oxygen can be a bridge, relieve the steric effect. The compound become planar. Non-planar compound become planar because of bridged oxygen. So if you count the pi bond, totally 5 pi bond, 10 pi electron. Charge is 0. Lone pair is 0. So 4n plus 2 pi electron system with 10 pi electron where n equals to the system definitely in conjugation and it is planar because of sp2 carbon. So 4n plus 2 conjugation planar mean the given compound is aromatic. Then the next example, you have fused system which is 6 member and 5 member. You should find whether the given compound is aromatic or not. Here you have fused system. Conjugated ketone is there. Conjugated ketone can create the partial positive charge because carbon is less electronegative than oxygen. So partial positive charge which help for delocalization. So totally if you count the pi bonds, 4 pi bonds, charge is 0. Charge contribution is 0 because positive charge cannot contribute to the system. Lone pair is 0. So it is a 4n system with 8 pi electron where n equals to conjugation definitely there because positive charge can support it and planarity also there. So it is a 4n system conjugated. Planar means the given compound is anti-aromatic. Then the next example, you have macrocyclic system with double and triple bond. You should find the given compound is aromatic or not. Here the system is big but it has 3 triple bond in the system. Triple bond only contribute 2 electron, not 4 electron because triple bond orbitals are perpendicular to each other. So only 2 electron participation. So if you count it totally 6 pi bonds including alkyne. So 6 pi bond means 12 pi electron. Charge is 0. Lone pair is 0. So which is 4 and pi system with 12 pi electron. The system is conjugated even with triple and double bond and planarity definitely there. So 4n system conjugated. Planar means the given compound is anti-aromatic. Then the next example. Here you have benzene fused with cyclohexene dione. We should find the given compound is aromatic or not. Here you have carbonyl. The carbonyl carbon has partial positive charge because of electronegative oxygen. The partial positive charge can help the delocalization. So if you count the pi bond, totally 4 pi bond which gives 8 pi electron. Charge is 0. Lone pair is 0. So it is a 4n pi system with 8 pi electron where n equals to the system is definitely conjugated because partial positive charge can support it and system is planar because of all sp2 carbons. So 4n system conjugated. Planar means the given compound is anti-aromatic. Then the next example, you have fused system which is 3 6-member ring fused together and anion. You should find the given compound is aromatic or not. Here you have cyclic system. Negative charge is there. Negative charge can support the conjugation and delocalization. So if you count the pi bonds, totally 6 pi bond which gives 12 electron and you have negative charge which can give 2 pi electron. Lone pair is 0. So it is a 4n plus 2 pi electron system with 14 electron where n equals 3 and the system is definitely conjugated. Negative charge can support it and planarity also there. So 4n plus 2 system conjugated and planar means the given compound is aromatic. Then the next example, you have quinoline which is fused pyridine and benzene. You should find the given compound is aromatic or not. Here you have nitrogen with lone pair. The system is also connected and cyclic. So if you count the pi bond, which has 8 pi bond, charge is 0, and it has one lone pair which should participate for delocalization as well as aromaticity. So it has 2 pi electron. So it is a 4n plus 2 system with 10 pi electron where n equals 2. The compound is definitely conjugated because lone pair can help for the conjugation, and definitely it is planar. So it is a 4n plus 2 system conjugated. Planar means the given compound is aromatic. Then our last example, you have cyclopropenyl anion. You should find the given compound is aromatic or not. Here you have 3-member system with one double bond. The negative charge can help for delocalization and provide the conjugation. So totally pi bonds, if you count 1 pi bond which gives 2 pi, charge is -1 which also give 2 pi. No lone pair is there, so 0 pi. So it is a 4n system with 4 pi electron where n equals 1. The system is definitely conjugated because negative charge can help for the conjugation, and planarity definitely there. So 4n system conjugated. Planar means the given compound is anti-aromatic. Here I given summary of the compound. These compounds can help you to practice the aromaticity and Huckel rule. This is the library of aromatic compounds. So more and more aromatic compounds. So more and more aromatic compounds. So more and more aromatic compounds. Then anti-aromatic compound. Better practice every compound individually. Then more and more anti-aromatic compounds. Then non-aromatic compounds. Mostly all are non-planar. I end up with the summary of Huckel table because without this table you cannot do anything. And one factor you should know here is lone pair always participate to create the aromaticity. That's all from this video. Thanks for watching. If you have any suggestion or feedback, comment below.